Okay, in this video we're going to do some practice problems to get ready for the test on section 6.4, and that's just covering the graphs of sine and cosine. So let's start with a nice easy one. We want to graph y equals 2 sine of x. So let's figure out the relevant parts here. We're going to need to know the amplitude of the function. And the amplitude is just the number in front of sine or cosine, so our amplitude is 2. And the period, how do we find the period of the function? It's 2 pi divided by the number in front of x. And in front of x there's a 1, so our period is 2 pi. And then are there any shifts, up, down, left, or right? Not in this one. So we have all our relevant information. Our baseline, so to speak, is going to be the x-axis. Our function will be wrapped around the x-axis. And we're going to go as high as 2 and as low as -2. And let's talk the period here. We got to chop up our x-axis. If we're just going to do one cycle, we could come out here and put 2 pi here. And visually, eyeball halfway in there, that would be pi. And then we'll have our half pi and 3/2 pi. So those are just the quadrant angles from the unit circle. And we're ready to start graphing. We need 5 points to graph our trig function. And this is sine, positive sine of x. So sine, it starts at the origin, and because it's positive, it'll tell us we'll start by going up toward a maximum value, or toward a peak. If it was negative sine, we'd start out by going down into a minimum value, or a valley. So the points I graph, I like to graph where I start first, and then for the sine wave we're going to end 2 pi later, right back on the x-axis. And in between these x-axis intercepts, we're going to cross again right in the middle at pi. And it's positive sine, so we will have a maximum value above half pi, and we'll have a minimum value below 3/2 pi. So we can connect the dots, and remember, it's not going to be a straight line. This is a sine wave. We have unwrapped the unit circle to create this. So you're going to have some curves, a little flow to it. And that'll work right there. Alright, number 2 is a simple cosine function. Amplitude, the number in front of sine or cosine on this is only a half. And it's cosine of 1x. There is an implied 1 there. So our period is 2 pi divided by that number in front of x, or just plain old 2 pi. And again, we don't have a shift up, down, or left and right on this. So our peaks are going to be as high as a half. Our valleys will be down to -1/2. And we chop up our x-axis. Just like the last one, these will be our quadrant angles. Now, when we started sine, sine started at the origin, and then you can put the dot where you're going to end, and you cross the x-axis in the middle. Cosine's a little different. Cosine is going to start at a maximum value or a minimum value, on a peak or in a valley. If it's positive cos, we'll start at a peak. If it's negative cos, we would start in a valley or at a minimum value. So this is cosine is positive, so our first point will be the peak up here at a half. And if we start there, 2 pi later, that's where we're going to finish. So this point in the middle now becomes the valley. In between these peaks, or these maximum values, we will have a minimum value. And then in between the peak and the first valley, we're going to cross the x-axis right at a half pi. And between the valley at pi and the peak at 2 pi, we're going to have an intercept at 3/2 pi. So there's our 5 dots, and we can connect the dots. Oop, that one's a little off, but I can fix that. There we go. Alright, simple sine wave. Ooh, now here something else is going on. This is a lot like the first one. Our amplitude, just like the first one, is 2, the number in front of the trig function. The period is 2 pi divided by the number in front of x, which is 1, so our period is again 2 pi. But now we have this stray number, 1 plus our trig function. You might also see that at the end, the sine of x, and then we would have plus 2. And if it's not in parentheses, that tells us it's a shift up or down. So we're going to have a shift, and the shift is going to be down 1 unit. And in class, this is not in the book, but my own vocabulary word, I've been calling this the baseline. Usually the x-axis is our baseline, and that's what we wrap our functions around. But now that baseline is changed. We're going to go down here to 1. Negative. Oh, no, this is positive. Excuse me, that's a shift up of 1, because this is a positive 1. So our baseline is going to be about here, +1, and I'm going to do a little dotted line so I don't lose track of my baseline. Now, from the baseline, we apply the amplitude. The amplitude is how high or low we go above that baseline. And now it's 2. So if we're here at 1 and we go up 2, we'd go up to 3. And if we go down 2, we'd go 0. 1 would take us to the x-axis, and the other one would take us to -1. So there's our highs and our lows. Our maximum value will be a 3. Our minimum will be a -1. We'll never go higher than 3 or less than -1. And our period's 2 pi, so we chop up our x-axis into quarters. Again, the quadrant angles from the unit circle. Okay, sine. If we were graphing just sine of 2x like we did in the first example, we would start at the origin, we would end at 2 pi, and we would cross in the middle. But now, because of this 1 at the lead of this trig function, everything's been moved up 1. Our baseline is 1. This intercept is 1. Our ending point has also been moved up to 1. Now, this is positive sine, so we're going to start by going up to a maximum value. That's still going to occur over pi and a half, or half pi, but it's going to be all the way up here at 3. And the 3/2 pi, that's where we usually have a valley, and now that valley just goes down to -1. Instead of down to, in example 1, it was down to -2. And we got our 5 dots, so we can connect them with a smooth flowing curve. Okay, the problem number one looked more like this. We had our sine wave without the +1. It was just 2 sine x, and we went up to 2 and down to -2. This 1 here just moved our 5 points, up, and that moved the whole graph up. Now, we have the sine of x and minus pi, and that is all within the parentheses. So that's going to be a shift to the left or the right. So let's start with the amplitude. The amplitude is 1. The period is 2 pi divided by the number in front of x, and it's again a 1, so our period is 2 pi. But now we have this, x minus pi. That's going to change our starting point and our ending point and our intercept and all our peaks and valleys. The most important thing is the starting point. Our usual starting point is 0. So we're going to set x minus pi, what is in the parentheses, we're going to set that equal to our old starting point. And we're going to solve that for x. We're just going to add pi to both sides, and we'll get x is pi. We could also find our ending point in a similar fashion. Sine usually ends at 2 pi. So we could set x minus pi equal to our old ending point, 2 pi, and then add pi to both sides, and get x equals 3 pi. So if we divvy up the x-axis, this would be 3 pi. Put 2 pi right about there, and 1 pi right about there. That's a little off, so I'm going to move this over. Oops. There we go. Oh, didn't mean to do that. There we go. Now, we're going to start at pi and end at 3 pi. Another way, an alternate way to find this ending point is, as soon as you know the starting point, we know this sine wave is going to start at pi, and we know the period is 2 pi. So if we go from the starting point out 2 more pi, 1 pi, 2 pi, that's also going to get us to the ending point of 3 pi. That's just an alternate way to find that. So, if that way appeals to you, by all means use it. So let's see, we're going to start at pi, we're going to end at 3 pi, we're going to cross in the middle at 2 pi, and then at the halfway points, this would be 3/2 pi, we're going to have a peak, and at 2.5 pi, we're going to have a valley. And I have yet to put the amplitude on my y-axis from 1 to -1. Okay, again, it's positive sine, so we're going to start out by going up, and we're going to hit a peak right here at 3/2 pi. And then we're going to cross at 2 pi. We're going to come down into a minimum value here at 5/2 pi, or 2.5 pi. And we can connect those dots with a nice smooth curve. Usually the sine wave is over here. It starts at the origin and ends, well, that should be about 2 pi there. My scaling's a little off. But what this minus pi did, it shifted everything to the right, pi radians. So now we start at pi instead of the origin, and we have our 2 pi cycle to end at 3 pi. If you want, we could take this to the origin. We really don't have to, but it looks like, we have a peak between 1 and 2, a valley between 2 and 3. So if we were to continue the natural flow of the graph, we're going up and we're going to come down. It doesn't make sense to put another peak there. This would be a valley down to a minimum value at -1, and then we would end at the origin. All right, number 5 now. Ooh, now we got something else going on here. That's a half x instead of 1x. So first thing, amplitude. For this, that's the number in front of sine, and that's a 1. Period. Here's what has changed. The period is 2 pi divided by the number in front of x. So we have 2 pi divided by a half. And to divide by a fraction, we invert and multiply. Multiply by the reciprocal. So that'll be 2 pi times 2 over 1, or 4 pi. And as I look more at the equation here, there's no vertical shift, there's no horizontal shift, so we're good to go. Our max value will be 1, our min a -1, and now our x-axis will go out to 4 pi for a cycle, and we're going to do 2 pi in the middle, and 3 pi is in between those, and 1 pi right there. So to graph this, we need 5 points. Sine starts on the x-axis, or its baseline. 4 pi later, this one is done with a cycle. It's going to cross in the middle at 2 pi. And because it's positive sine, we're going to start out by heading up toward a max value, a peak above pi. And that means we'll have a minimum value, or a valley, below 3 pi. And now that we got our 5 points, we can connect the dots with a nice smooth curve. Usually the sine wave starts at the origin, ends at 2 pi. So that's usually what our sine wave looks like. We have a peak at a half and a valley at 3 halves. But this 1 half in front of the x sort of tweaked it, and it stretched out our sine wave all the way out to 4 pi. Okay, one more, and this is the best one. We got a little bit of everything going on in here. I guess the only thing that wasn't really changed is the period. The period's just going to be 2 pi again. So amplitude. The amplitude, the number in front of the trig function, is a 2. The period. The period is still 2 pi divided by the number in front of x, which here is just a 1, so our period is 2 pi. But let's check out our shift, the shift. So this -1 outside the parentheses tells us we are going to be moved down 1 unit. The plus pi in the parentheses tells us we're going to have a new starting point and ending point. I can set what's in the parentheses equal to 0, our old starting point on the y-axis, and solve for x. So x is -pi. And I could set x plus pi equal to the old ending point 2 pi, and subtract pi from each side and get x equals +pi. So we're going to start at -pi, end at +pi. So if I come over here and make this -pi, about equidistant over here, this would be +pi. That's where we're going to start and stop. The baseline, our shift down, was 1. So now we're down here at -1, and I'm going to put a little dotted line there to remind myself that that's the baseline. And from the baseline, we can apply the amplitude. Amplitude was 2. So if we're at -1 and we go up 2, we go up to 1. If we're at -1 and we go down 2, we'll go down to -3. So we have our range, on the x-axis we're going to graph. We have our range on the y-axis. Looks like we're about ready to plot some points. So let's see, cosine, it's positive cos, so we will start at a peak. We're going to start here at -pi, and the peak height is up at 1. And then 2 pi later, we're right back at another peak up here at 1. And right in the middle of these peaks, we will have a valley, and that hits the y-axis all the way down here at -3. Now, the number one mistake that I've seen students make after a few years here, they want to put these intercepts, the midway points, right on the x-axis. That gets to be a habit. But remember that -1 has shifted everything down. So these aren't x-intercepts, they are baseline intercepts. So we got to slide those down onto the baseline. Now we're ready to graph a cycle. So we started our peak at 1 above -pi. Across the baseline at -½ pi, into the valley on the y-axis. +½ pi, we're back to the baseline, and by the time we get to pi, we're done with the cycle, we're back at a peak. If we wanted to do another cycle, this would be 2 pi, so we would have a peak here, valley in between, and we would cross the baseline at the midway points. A little something like that. So there's some practice to get ready for the test tomorrow. Good luck.